Good afternoon to everyone. Today I am going to discuss about a Trun-Off fluorescence sensor for ascorbic acid based on organic synthesis via the fluorescence resonance energy transfer. This is content of my work. First one is the introduction, second one is the objective, third one is result and discussion, finally summary. The introduction. Introduction. What is meant by the biosensor? The biosensor is an analytical device used for the detection of an analyte that combines a biological component with the physiochemical detector. These are the four different type of the biosensor. First one is the optical biosensor, electrochemical biosensor. Third one is the physioelectrical biosensor. Fourth one is thermometric biosensor. This figure will be represented schematic representation of the sample unlike will be varied. The selective bioreceptor also using the selective bioreceptor is the immobilized enzyme and bioorganism and bioimmunoagents and DNA and whole cells also. This further the converted into the transducer. The transducer is a different form of the transducer. It's applied in the electrochemical and potentiometric and ambiometric and optical and absorption and fluorescence and reflection and physioelectrical also. It finally converted to the signal and final the data processing. Then optical transducer. Only our work will be mainly focusing on the optical transducer. So what is meant by the optical transducer? The optical transducer are the sensors that are used to convert light rays into electrical signal. This depending upon the two importance law. First one is the relationship between the incident light intensity and transmitted radiation is given by the Peer-Lambert's law. The A equal to epsilon CL. A is absorption, L is path length, and C is concentration. And second one is the light incident on the interface between two dielectrical media is either reflect or refract according to the Nell's law. And further the fluorescence. The fluorescence is the emission of light by a substance that has the absorbed light or other electromagnetic radiation. The emitted light has a longer wavelength and therefore the lower energy than absorbs the radiation 10 to the power of minus 9 to 10 to the power of minus 7 second. In this case, the fundamental concept of the Jablonski diagram is S0 in the when a molecule is S0 to S1, this is the ground state to the excited state. The energy will be the change, the different variation also. This is the S1 to S0. This process will be the fluorescence. The fluorescence will be 10 to the power of minus 9 to 10 to the power of minus 7 second. In case the S1 state to the interconversion process delayed fluorescence in this ground state. This is the phosphorescence and non-radioactive relaxation also. The phosphorescence will be the 10 to the power of minus 3 to 10 to the power of 2 seconds. And the vitamin C, only our group will be detection of the vitamin C, the ascorbic acid also detection. So RTA, the recommended the daily allowance of the vitamin C is follows: 75 microgram for females and 110 microgram for female smokers and 90 microgram for males and 125 microgram for male smokers. And the main objective in our paper to develop a simple fluorescence based biosensor for ascorbic acid biomolecules. Second one is the designing of biosensor by utilizing the simple chip based a simple platform. Third one is that to thoroughly the characterized the developed biosensor using the UV visible and emission spectral techniques. And further DFT studies was confirmed. Finally, the to apply this analytical tool for real sample analysis and the synthesis of our group. First of all, first one is the 9-anthracene and second one is the luminol. The two reactant molecule will be dissolved into the ethanol solution and the addition of acetic acid medium in the, under the ultrasonication method via greener approach and 30 minutes will be applied. And further the product was confirmed by the TLC chamber and TLC plate and 1:4 diethyl ether and pet ether process. And finally the product yield was calculated 98% of. And further the structure was confirmed by the mass spectroscopy. The mass spectroscopy, the M plus is that 367 molecular weight. And further the H1 NMR and C13 NMR, the structure also confirmed by the ATT probe. In this case, the imine will be attached to the CH. The CH proton will be appearing at 8.97 ppm. And then this luminol will be attached to the NH and NH. The hydrogen proton will be appearing at 8.71 ppm and then 6.51 ppm. And the other region also aromatic region of the hydrogen. C13 NMR. C13 NMR peak was imine peak was attached to the carbon. The carbon range will be the 193 ppm, and then further the ppm range will be 160 ppm range to 118 ppm, also the aromatic range of the carbon peak. And third one is the IR spectrum of the data and the ATT probe and the ATT ascorbic acid. First one is the ATT probe. The ATT probe will be, and the CH, the imine touching frequency was appeared at 1659 centimeter universe 1, and then carbonyl touching frequency, so strong touching frequency is applied for the 1600 centimeter universe 1, and the NH touching frequency at 3019 centimeter universal. And further, the addition of ascorbic acid is guiding the UV visible spectrum, FTIR spectrum of the OH, the touching the broad range of the OH peak was appeared, and the range of 3022 centimeter universe 1, and then ester peak, the COO, the 1757 nanometer. And this is the procedure of detection of ascorbic acid using the ATT probe in UV visible and fluorescence methods. First, this is the also condition. This is the optimized condition, the 2 ml of buffer solution, pH 7.4, then the 50 microliter of 10 to the power of -3 molar ATT solution, and then 5 micromolar concentration of ascorbic acid were added. Then the mixture was shaken thoroughly and kept for only the 2 minutes. After the UV visible spectrum were recorded, this absorption of the maximum was used for the detection of ascorbic acid. Second one is the room temperature with 1 ml of 0.1 molar buffer solution, pH 7.4, then 20 microliter of 10 to the power of -3 molar concentration of ATT solution and 5 micromolar concentration of the ascorbic acid were added. The mixture was shaken thoroughly and kept for 5 to 10 minutes. After the fluorescence spectrum were recorded from the 430 nanometer to 700 nanometer with the excitation wavelength of 405 nanometer. The slit width of excitation and the emission were 5 nanometer. The fluorescent intensity of the maximum intensity was used for quantitative analysis of the ascorbic acid and result and discussion. In this case, UV visible spectra and emission analysis. The UV visible spectra studies. First one is the A will be represented. The UV visible spectrum of the ATT probe is the 3 major absorption peak what is appeared. First one is the ATT probe and 263 nanometer peak of the sharp absorption peak, and the another 2 peaks are the solder peak, 374 nanometer and then 411 nanometer also. And further Phi will be represented to the addition of the ATT probe and the addition of ascorbic acid into 5 micromolar concentration to 125 micromolar concentration. The absorption range will be gradually decreased. C will be denoted the enlarged UV visible spectrum ATT probe in the presence of ascorbic acid at 374 nanometer and 411 nanometer range, and D will be represented the corresponding the linear platform. And the selective and commutative behavior of ATT in presence of other interference. In this, the selective studies of the ATT probe in the presence of interfering the biomolecules and metals and amino acids like the calcium chloride, calcium carbonate, dopamine, glucose, urea, uric acid, homocysteine and tryptophan. In this case, only the ascorbic acid has selectively the absorption peak was decreased. This is selective detection of ATT probe through the ascorbic acid. This is the corresponding the bar diagram. This one is L will be L represented to the ATT probe and attached to the ascorbic acid. This case, another evidence of the competitive studies. The competitive studies of in the presence of ATT probe, in the presence of higher concentration of the interference molecule and dopamine, glucose and etc. Then no change of the absorption spectra. So this is the corresponding the bar diagram. And the fluorescence response for the ATT towards the ascorbic acid and pH effect. In this pH effect, first one is the effect of pH studies of the ATT probe in the presence of different pH in the emission spectra. In this case, the linear platform of pH 3 to 5, 3 to 5 decrease, increase 3 to 5, the ATT probe will be protonation, and then pH will be increasing the 8 or 9, the ATT probe will deprotonation. In this case only the pH 7.4 only the strong emission intensity. So further our work will be fixed in pH 7.4, 7.4. And further this A will be represented in ATT probe with this sharp emission peak at 521 nanometer. And further the addition of ascorbic acid, the emission intensity was gradually decreased. This is the gradually decreased the concentration range at 5 micromolar to 190 micromolar concentration. And further, this one is the linear corresponding spectrum, and these are the Stern-Wolmer equation. The selective and competitive analysis based on emission change. In this case, the selective studies. In the selective studies of the ATT probe in the presence of other interference, the dopamine, glucose, and etc. Only the ATT probe is strongly binding to the ascorbic acid. The emission peak was gradually decreased. So this is also the corresponding the bar diagram. The M will be denoted to the ATT and the ascorbic acid binding constant. And further, this is the higher. This one is the lower concentration of competitive studies of the emission spectra. In the higher concentration of the emission spectra, in this case, no change in the higher and lower concentration of emission spectra. These are also the corresponding the linear platform in the presence of the other interference molecules. Then the Jobs plot also confirmed. The Jobs plot they determined the stoichiometric binding between the ATT probe and ascorbic acid in the pH 7.4 in buffer solution. In the system is perfectly the concluding the emission spectrum of the ATT probe and ascorbic acid to determine the 1:1 stoichiometric binding. And the DFT and the DD-DFT studies, this A will be this one is the ATT probe, power probe, and then for the ATT probe, the HOMO to LUMO, the energy difference between the 3.105 electron volt, and then further the addition of ascorbic acid, the HOMO to LUMO, the energy will be the change, and the electron will be the 3.2139 electron volt. The energy difference between the 0.061 electron volt. In this, the ATT probe and ascorbic acid, the interaction to the hydrogen bonding interaction. In this case, the selective binding to the ATT probe and ascorbic acid compared to other interference molecules. And the mechanism for the proposed biosensor, the ATT probe and AA. First of all, the ATT probe initially the tan fluorescent nature. In further the addition of ascorbic acid, the FRET mechanism will be applied. The FRET mechanism is denoted the acceptor absorption and donor the emission. This is the overlap. This is the slightly the FRET mechanism will be applied, and further is the hydrogen bonding interaction also. This is the ATT probe of the OH and the ascorbic acid, the OH molecule. This is the interaction to the hydrogen bonding interaction. This mechanism will be two mechanisms will be applied. One is the FRET conjugate mechanism, and further one is the hydrogen bonding mechanism. And the real sample analysis. In the real sample analysis, the emission spectrum of determining the ascorbic acid in the various food samples and lemon, orange, etc. And 14 sample may be used. This the optimized condition. This is the real sample lemon, and maybe 15 sample, and dilution factor is the 10, and determination of the unknown concentration of the 5 micromolar, and spiking the different concentration and overall concentration is finally the recovery also calculated. Is the good recovery rate will be appeared. This table will be denoted the comparison of the previous ascorbic acid table. This is the maximum work will be only the nanomaterials and graphene quantum dots only using, but our work is recently the fluorescence detection method will be fluorescence, and then materials will be the image synthesized is easily the cleaner approach also. The LOD range will be the 10 nanometer, and the linear range is the 0.25 to micromolar to 190 micromolar concentration. This is the current our work. And the summary, a very simple and low cost effective biosensor. Second one is the Trun-Off response for the ascorbic acid in FRET mechanism. Third one is the job spread has clearly evidenced the formation of 1:1 binding mode of the ATT probe in ascorbic acid. Fourth one is the conjugate constant, and the efficiency was calculated the KSB 1.7491 into 10 to the power of 8 molar, and then conjugate concentration of the 53 point respectively. and quantum yield of the ATT molecule was calculated 83%. And then as per fluorimetric sensor and ascorbic acid, the linear range from 0.25 to 190 micromolar and the LOD range is 10 nanomolar, and finally the good recovery in the real sample analysis. Thank you.